All right, in this lesson we are going to take a look at trig identities and use them in trigonometric proofs. Now, hold on. I know you see the word and you hear the word proof and you're like freaking out. I can't do proofs, right? You're thinking about geometry proofs. Not the same. It's algebra proofs, okay? And all you're gonna do, you're gonna be asked to work with one side of an equation and make it look like the other side. It's not that bad, okay? It's really not that bad. Now, in order to do that, we have to review some identities we already know and learn a new identity in three forms, okay? So, we have secant equals 1 over cosine. We know that because cosine is the reciprocal of secant. So this is secant over 1, for example, right? And you just flip that and it becomes 1 over cosine. So that is how that works. Cosecant is 1 over sine. Cotangent is 1 over tangent. Now we know that stuff already. We also know that tangent is sine over cosine. Very important. And therefore the cotangent, the flip of the tangent, you just flip that and you get that, right? So you get cos over sine. Very important that we know those. We're going to be using these and substituting these into our, I don't know why that's like a delay there. All right, my eraser is a delay. Okay. So now a new identity we're going to learn. And this is called the Pythagorean identity. It's sine squared plus cosine squared equals 1. The reason why is because if you think about a triangle, you know, the reference triangles we did, remember those? We learned that cosine is just the x and sine is just the y. So x is to the right and y goes up, remember that? And this is the radius, okay, of the circle, if we drew that circle in there, okay? There's your reference triangle, okay? We have x, y, r. We've seen this diagram before, all right? Well, cosine is x, so I can replace that with cosine, and y is the sine. We're talking about a unit circle here, okay? So y is sine, cos is x, and r, the radius of the unit circle, I should put unit circle here. Unit circle. If we have a unit circle, it's cosine, sine, and then 1. So if I use logic and the Pythagorean theorem, I come up with a squared plus b squared equals c squared. If this is ABC, I just plug in sine squared plus cosine squared equals, and then c would be the radius. It's 1 for a unit circle because the radius is 1 squared. And then, of course, sine squared plus cosine squared equals 1 because 1 squared is just 1. That's where that Pythagorean identity comes from. You just got to memorize it. It's just something you're going to have to memorize. Whenever you see in an expression sine squared plus cosine squared, you're going to take it out and replace it with the number 1. Just 1. It's nice and easy. Now, from this, erase all this here. From sine squared plus cosine squared equals 1, we get two more identities just by transposing something to the other side of the equation. If I subtract cosine squared theta to the other side of the equation, that's a zero pair, and I'm left with sine squared equals 1 minus cosine squared. So I get this guy, okay? If I do the same thing except instead of subtracting cosine squared, I subtract sine squared to the other side, minus sine squared theta, minus sine squared theta. Boom. What do I get? I get cosine squared theta equals 1 minus sine squared theta. And you can't do that because you can't do 1 minus sine squared because I don't know what, they're not like terms. I don't have a sine here or a sine squared to combine it with. So it literally just stays 1 minus sine squared. And I get this. Cosine squared equals 1 minus sine squared. There it is. Okay? I didn't mean to write on that. So there's I actually have 3 trig identities, but they all come from the same identity. They come from the Pythagorean theorem. Okay, so Pythagorean theorem gives me this, and that can go to that, or it can go to that. 3 different things. If you see sine squared plus cosine squared, you're going to replace it with 1. If you see 1 minus cosine squared, you're going to take that out and replace it with sine squared. If you see 1 minus sine squared, you're going to take it out and replace it with cosine squared. That's what we're going to be doing in these trig proofs. Now, before we get into the proofs, we're just going to rewrite some expressions a different way. It'll kind of warm us up to doing the proofs. They want us to rewrite in terms of sine theta. That means your answer should have sine in it, and only sine, nothing else. You could have sine squared, you could have 1 over sine, you could have something like that, but you can't have cos, you can't have tan, you can't have cosecant. In terms of sine means just sine should be in your answer. Sine is the only function that should be in your answer. So we're going to do that by making substitutions. Now, we already know that secant is 1 over cosine. We know that cosecant is 1 over sine. And we know that cosine is just cosine, so we're not going to do anything with that. So we're going to substitute. We're going to take out secant and we're going to replace it with 1 over cosine theta. We're going to take out cosecant and we're going to replace it with 1 over sine theta. And we're going to leave this alone. And we're just going to put it over 1. Cosine theta is the same thing as cosine theta over 1. Why? Just so we have it nice and consistent all the way across. And now we can use our multiplication skills. We know how to multiply fractions. We should. We factor them and then we cross cancel. Well, they're already factored. There's nothing to factor here. So we have a cos here and a cos here. Those reduce to 1. That's 1, 1. And what are we left with? We're left with 1 over sine. And that is our answer. It said write it in terms of sine. And we have it in terms of sine. We got rid of the cosine. We got rid of the secant. Those turned into cosine. We got rid of those, and we're left with just 1 over sine. This one here is a little trickier because we have a fraction already. So cosine is just cosine. Put it over 1. Tangent is sine over cosine. So the top of the fraction, I haven't done anything with this yet. The top of the fraction is this. Okay? So let's do that first. That's going to be just sine because the cosines cancel out, right? And you're left with just sine. So now I have sine over cosecant. Well, cosecant is 1 over sine. So now it's sine theta over 1 over 1 over sine. Now, where did I get that from? Well, the sine is just that, and the cosecant is just that. Okay, so I have sine over 1 divided by 1 over sine. And we learned how to divide fractions earlier in the year, right? We do, and I'm going to go up here because I'm out of room. We do, so I'm going up here, okay? We just do sine, and we keep change flip. We multiply, and then we flip this. So it becomes sine times sine, which is sine squared. And that is my final answer. Okay, so you got to do a little bit of algebra, basically, with your trig functions. So this one here, I'm going to rewrite. This one's going to be, tangent is going to be sine over cosine. Okay, why'd that turn black? And this, so tangent is sine over cosine. Cosine is going to be cosine over 1. So again, I have that complex fraction. I have a fraction in a fraction, two fractions in a fraction. So, but this means divide. So this is the same as sine over cos times 1 over cos. So that gives me sine over cosine squared. Now, what am I trying to do? I'm trying to write in terms of sine. Well, I got to get this cosine squared out of here. Guess what we learned, though? We learned that cosine squared, right here, we learned that cosine squared is equal to 1 minus sine squared. So if I want to have it in terms of sine, I got to get rid of my cosine squared. I got to take out cosine squared, and I got to replace it with 1 minus sine squared. So this is going to be sine over 1 minus sine squared. So this lesson is basically where algebra meets trigonometry. Okay? Algebra meets trigonometry. Everything we did earlier in the year with multiplying, dividing, adding, subtracting fractions of x with x's and y's and a's and b's and r's and s's. Now you need to use those skills with sine, cosine, tangent. Okay. All right, and this one here is going to be secant is going to be 1 over. Here, I'm going to change to black here. So secant is going to be 1 over cosine. Let me just draw a separator. 1 over cosine times, that's this times here, and then cotangent is going to be cosine over sine, but it's squared. See how it's squared? So we're going to square both of these. All right. So now this cosine reduces with one of these. Cosine squared is really cosine cosine. Right? So I can do that. I can reduce this cosine with one of these cosines. And now I'm left with cosine over sine squared. I want in terms of cosine. So I want to take out my sine squared, and I want to replace it with 1 minus cosine squared. And I'm going to leave that right there. And that's all I can do. I have it in terms of cosine. There's nothing else I can do there. I can't reduce a cosine because it's a binomial. It's a binomial 1 minus cosine squared. Just like if you had x over 1 minus x, you can't reduce those x's because 1 minus x is a binomial, right? So same thing here. 1 minus cosine squared is a binomial. You don't have a common factor, therefore you cannot reduce with a cosine on top, okay? And now that leads us into our proofs. Big part about the proof is, and they got us on the Regents exams right from the first Regents exam in Common Core here. You can only work with one side of the equation and get the other side. You can't substitute. So see how this goes? Sine times secant equals tangent. You could replace tangent with sine over cosine, but then you can't touch this side. It's one side or the other. So what you're trying to do is make this side look like this side. So let's keep the tangent. We're going to keep the tangent in a box. We're not going to touch it. We're going to keep the cosecant alone. We're not going to touch it. We're going to keep tangent alone. We're not going to touch it. So basically, they're telling you what the answer is going to be. When you do this, you should get tangent. When you do this, you should get cosecant. That's a proof. You're proving that it works, but you got to show the work. That's where you're getting graded on. Okay, so sine is just sine. We're going to put that over 1. And then secant is 1 over cosine. Okay, so nothing, and that equals tangent. We're just going to keep carrying that down. Now, can't do anything, nothing cancels out, but now you can multiply, put them together. So we're going to have, this is going to be sine over cosine equals tangent, but Doesn't sine over cosine equal tangent? So now your last step is tangent equals tangent. Tan theta equals tan theta. There it is. And you just put a little check, and you prove that tan theta equals tan theta. So you prove that both sides of the equations are equal. That's all it is. That's a trigonometric proof. All right, so again, we'll leave that alone. We're going to make substitutions here. So this is going to be cosine squared. Actually, we're not going to make a substitution. We're going to put this over 1, and we're adding fractions, so we got to get a common denominator. So I have cosine. We're not going to touch this one. Okay. Now here I need to multiply by what to get the common denominator of sine? I'm going to multiply by sine. Multiply by sine over sine. Why? Because I want to get to match that. I want to get the common denominator. So now I'm going to have sine squared on top. See that? Sine squared right there. Over sine. Okay? And that should equal cosecant. Not yet. It doesn't yet. Now I have a common denominator, so I'm going to put them together. Cosine squared plus sine squared over sine equals cosecant. Now I got to use my identity from the front page. Cosine squared plus sine squared equals 1. So we're going to take out cosine squared, sine squared, replace it with a 1. So it's 1 over sine theta equals cosecant theta, and that's the definition of cosecant. 1 over sine is cosecant. So now I could say cosecant equals cosecant, and I am done. All right, one more. Switch colors. Here I'm subtracting. I need a common denominator. I have, well, let's see. I actually have a lot of stuff going on here. Let's do this. Let's get the common denominator first. So I have this one's going to be a little bit long. So I have cosecant. Now what I like to do sometimes is I don't write the theta because they all have theta with it, so it's kind of like just repetitive. So I'm just going to say cosecant over cos minus cos over sine equals tan. I'm not going to keep writing equals tan. I'm just going to carry it down. Okay. So there we go. I need a common denominator. Well, my common denominator has got to be cos sine. Cos sine. So I'm going to go times sine here and times cos here. Okay, just like if you had a times x or times 2 or times whatever, right? Just like we did earlier in the year. All right, so we have sine times cosecant. This is sine times cosecant over sine cos minus cos squared over sine cos. I have a common denominator. I'm going to put them together. One fraction. Sine cosecant minus cosine squared over sine cos. And again, that equals tangent. I'm just carrying it down. Now what do? Well, I got everything in sine and cos except for this guy right there. I have a sine cosecant. On the side here, I want to do sine cosecant and show you what it comes out to be. Sine times cosecant is the same as sine times 1 over sine, because cosecant is 1 over sine. If you do sine times 1 over sine, don't the sines reduce to 1? What are you left with? You're left with 1. So sine cosecant, because of that, is really just 1. So this is 1 minus cosine squared. Sometimes you got to do a little work on the side. So it's 1 minus cosine squared over sine cos equals tan. 1 minus cosine squared from the front page is sine squared over sine cos. We're getting there. Sine squared, isn't that just sine sine? Sine squared is sine sine. Sines cancel. I'm left with sine over cos, and sine over cos by definition is tangent. So tan theta equals tan theta, and I have shown why. I have progressively shown why tan theta equals tan theta, why the left side equals the right side. We will practice these in class tomorrow, and of course, every day after you're going to have like one to do every day. You'll get a little bit better at them as we go along. I will see you tomorrow.